Hello everyone, this is Scott Moore on behalf of the Automated Software Testing and Quality Summit. Today I'm going to be talking about the importance of doing performance engineering when you're doing a cloud migration. So thank you for having me. It's a privilege to be here. Let's jump right into the presentation. So what are we going to talk about today? Well, we've got a problem. A lot of companies are now leaving the cloud that went to the cloud just a few years ago, or they're pulling back at least partly. Why is that? Well, there's for a lot of reasons. We'll talk about why that is and what's causing it. We'll also talk about something called the super cloud. Sometimes it's referred to as the meta cloud or hybrid cloud. And it's much more than just using multiple cloud vendors or a on-prem and cloud solution at the same time. We'll talk about performance engineering and where the real value is for it, because it's more than just load testing. For years, we've heard you need to load test, and if you're in the cloud, load test the cloud from the cloud. Yeah, but that's just one part of the performance engineering discipline. We'll talk about what it all includes in this presentation as well. But the real piece that I want to focus in on is where we get value from when we're doing performance engineering, because we're not seeing a whole lot of that en masse like I believe that we should. Let's get into that. Why are companies now repatriating? That's now a new term, cloud repatriation. Why are they doing that? Well, it's for a lot of reasons, which you can see there. In 2021, an article was recently released that said in 2021, about 80% of companies in the US pulled back at least part of their workloads. And that's because of three killers. One was cost, and that's the big reason. Two, complexity. And three, control, meaning lack of control, things they couldn't control that they wanted to control. But it's basically that many companies are now adopting a hybrid cloud solution where they have some of their workload back on-prem that they want to control or reduce the cost of, and then they use the cloud for things that they still want to get the benefits of. Like with the cloud, you do get some capabilities or abilities that we talk about that include scalability, reliability, resilience, and other things that the cloud does provide. However, it also allows for things like shadow IT. It enables company employees to kind of do their own skunkworks projects and sometimes go around a process. And when you're having to do things to go around a process, the process becomes the biggest point of friction. Then you got bigger issues. And this shadow IT can be very costly as well when developers begin to be responsible for owning their own environments and creating an environment. And sometimes those developers aren't cloud architects. So it ends up costing more money than you thought it would. Also, boosting data security. There's some information that you don't want to be on the cloud because there's a risk of it leaking. And we've seen a lot of reports from just recently about government entities and large companies losing critical data from servers that were storing large amounts of data that were wide open and shouldn't be. And because of that, new regulation has come out that's forced companies to pull some of that information back on-prem that should have probably never been in the cloud to begin with. And in some cases, people have realized that their applications were not optimized for the cloud, and they need to do that and refactor it before they put it out there, so they're bringing it back. They're also trying to obviously lower costs because that has spiraled out of control, and I'll talk more about that next. But as you are in the cloud and you see that maybe you are in a vendor lock-in situation, you're going to want to move possibly to another provider to save money. A lot of it has to do with saving money, and there's a lot of information to support that on the web. Someone that you should be following, if you're not, is David Linthicum from Deloitte. He writes a lot about this cloud repatriation. And let me just share an article with you, which he talks about 2023 possibly being the year of public cloud repatriation. Again, cost and complexity being higher than expected. Many enterprises are making a U-turn and putting applications and data back on traditional systems. Now, here's a few examples of why the cost is an issue. Here's a company called Pre-Render that reduced their annual server cost by 80% from $1 million to $200,000 by moving some of that workload off of AWS that was prohibitively expensive. Just about a month ago from when this presentation was created in March of 2023, Singapore, a firm in Singapore, showed that they could save $400 million by not moving their application to the cloud. I mean, these are large amounts of money that if you can save and put in other places, it makes a big difference. But that doesn't mean that everything needs to be moved off of the cloud immediately just because of maybe one area being cost prohibitive. Everybody probably realizes that if you were to just make this wide U-turn, you wouldn't be moving back to what you had before anyway, because there are things that you are getting out of the cloud that you're not getting on-prem that you still need. So let's talk about some of that. When would it not be a good idea to shift back to on-prem? Well, first of all, things that are very repetitive and routine that are just increasing your cost, which you can save a lot on, like things like data, especially large amounts of unstructured data storage that you have. Those you can probably get up to 60 up to 80% savings by moving that back on-prem. If you never made a significant investment in rewriting a bunch of APIs and you just shifted an application to the cloud without doing any of that, it might be easier to bring that back on-prem. But if you have done that exercise, it may not. And the other big issue is if you move it back, will you still have the people in-house with the right skill sets to maintain those applications on-prem? Because many companies were advised to go all in on cloud. They either got new employees who were already skilled in cloud, or they upskilled the people that they had onto cloud, and a lot of that information has gotten forgotten because they didn't think they were ever going to go back to that. So if you're thinking about saving money by moving off the cloud onto on-prem, do you still have those people with the resources and able to do that? Because that is going to be a cost. And once you actually figure that cost and benefit out, you might be at a break-even point, because skill sets are right now in great need right now in companies. I think the biggest offender is not optimizing the applications before you shift it over. So there's two reasons for that. One is you had companies who were advised early on, 5 to 10 years ago, you got to go to the cloud, get rid of all this on-prem stuff. This is the future. Go cloud first. This is the coolest idea, and everybody's doing it, and not realizing that without optimizing and just going all in, there might be a big pay out that you're going to have to make to a cloud vendor, and people realized that too late, and then they were kind of locked into it and they couldn't really do much about it. And okay, now you get AWS, then Azure comes along, then Google Cloud Services and other ones, and you start pricing them out, and it's cost more for you to actually do the exercise to shift from, say, Amazon over to Azure than it is to just stay where you're at and figure out how to try to save money where you're at. So the move over adds to the complexity to it as well. So that brings us to multiple cloud vendors. You're going to hear about this term, I believe, in the next 12 to 24 months, a lot more than you have in the past. You hear VMware talking about it a lot now. David Linthicum, who I referenced just earlier, is talking a lot about this. It's the concept of a super cloud or a meta cloud. I hear super cloud more than anything. And what that is an abstracted layer above all of the individual cloud vendors that no matter how they operate a particular service, and some of them can be vastly different than others, there will be a small layer of services around data and security, authentication, things like that, that operate above that. And so you could build your applications once, they could run on multiple clouds, access those underlying services, no matter how different they are, and the user doesn't really even care. Like when I'm rendering a page that's being shown, maybe this time it's coming from an Amazon server, an Amazon compute power. The next time it may come from Google. 15 minutes later. These can be containerized applications. These can be microservices applications across multiple cloud vendors. And let's face it, the cloud vendors really need to get on board with this, because none of them individually can take all of the traffic from all the companies all the time. So they really need to work together. And it's not like we don't have stories that show that a single vendor being relied on for the cloud can be a bad idea, because we've had major outages on AWS before, and it takes down 40 or 50 of the largest, most known tech companies with it. And they've realized they've got to have a multiple vendor solution. Now, quick question about that. Even if you have this simplified abstraction layer that allows you to build the app, deploy it once, and go across multiple cloud vendors, underneath all of that, would that be more complexity or less complexity? Yeah, more complexity. And when you have more complexity, is there a need for more testing or less testing? Yep, you guessed it. More testing. And so that's why I believe that automation is really the only way that you're going to dig yourself out of this complexity hole. Now, I'm talking not just about functional automation for functional testing and automation for performance testing and load testing, but also those site reliability engineers who are the designated team members trying to get rid of as much toil and manual labor out of the organization as possible. And they believe that automation is the way to deal with that. So think about RPA solutions, where you get the benefit of not just being within an application doing happy paths and accomplishing, but accomplishing work where you may go to a web application, pull information out, open up a Word document, paste something in, and then push that information, upload that document into something else, and then pull something from a green screen legacy application, where right now you don't have the integration, or the interfaces don't work together right now. It's making those things work upstream and downstream until you get there. I think it's a combination of all of that. It's all of the automation solutions that you have in the testing realm, the RPA realm, and in the site reliability engineering realm. Everything that can be automated should be automated. And as things get more complex, you will need more automation, which probably even means you're going to need a little bit of help from AI and machine learning to help speed up that process as well. So when companies begin to shift to the cloud and they start experiencing performance issues, here are the biggest concerns and the biggest things that we see that go wrong, that where the applications are not optimized. The first thing we start worrying about is latency, because it really doesn't matter if you have a great pipe, a great code. If there's latency between 2 points and the latency is great enough, you will experience slowdowns with your application, and your users will know it immediately. And it could be something as simple as deploying a content delivery network like a CDN for your web page, where the static web content can be cached in locations that are closest to the user accessing it. Somebody who's accessing a website from Japan and the servers are in the US Northeast region are going to be slow unless you had a server with those cached assets in Japan closest to the user, where they could pull those back a lot faster. That's just one way to reduce the latency of pulling back information. I mean, it could be as detailed as how somebody goes from the US to Japan, which direction around the globe across the network they go, to reduce that latency for every trace route, every ping time to be reduced, and reduce that latency, the better you're going to see performance in your application. The next thing is network congestion. Again, you can have a very large pipe where data is passing through, but you need to consider how often your application is passing information, how chatty your application is going back and forth across the network. What is the network that it's passing across? Is it a really good internal LAN, 10 gigabit connection, or is it a 4G LTE cellular tower connection out in the field? Those applications need to be written for the network. Even if they're accessed from the cloud, that edge component can be the issue. And not only how often your application is chatting across the network, but how big is the payload that you're passing across for each transaction across the internet? What protocol are you using? Is it a very heavy protocol? Is it low level TCP/IP? Is it HTTP version 2, version 3, quick? I mean, what are you using? The next issue is scalability. And here's where you have to ask yourself the question, is this where the cloud really plays a great role, because it does have the ability to auto scale and grab more resources. But you have to ask the question, is it going to scale for one? Is it going to meet the performance requirements for one? And is it going to scale for many? And that has to happen at the lowest levels of code and features and functionality, as well as in a very large level, the integrated test, the overall performance test and load testing that you're running. The next one is resource allocation. Again, the cloud is great at this because it provides a lot of additional resources when you need them. If you don't have a lot of traffic between these certain hours, you can reduce the amount of resources that you're utilizing, which means you're not paying for the accessing of that infrastructure and those resources. But more demand may be placed on those resources, which means you need more of them, and then it expands, cost you more. And here's where performance engineers would help you optimize that so that you use the lowest amount of resources but still get the amount of performance that's required from the users, those low latency and the scalability, but at the lowest cost. So if you're accessing additional resources because you need them because the demand is being placed on the system, that's one thing. If it's because your code is written poorly or your system has been architected in such a way that you're just overusing resources because it's a hog, that's a different story. Thus, why performance engineers are worth their weight in gold. And so the final one I'll mention is around security. Now, security and performance are in much ways, they're very parallel, because if you were to take a load test, remove all of the think time out of the load test and just ram all the users at the system without any sort of pause times or anything like that, that's pretty much equivalent to a denial of service attack. The objective, obviously, on the security side is let's remove anybody else being able to access the system because we're utilizing all of those resources that are available. And so what that brings up is the need for a strategy to deal with that type of attack. And that comes from bots. I want to show you this article from Light Reading that talks about 42% of the internet traffic comes from bots. So think of it in two ways. You have bots that are going out there possibly trying to take your website down because of a denial of service attack, but you also have bots out there. Let's say you're a retail shop and you're selling something online and you have competitors who are wanting to competitively shop and compete with you online. They may have bots running 24 hours a day to find out what your prices are so they can beat them all the time. That's just one example. But that's not human users doing that. But guess what? Every time that bot runs against your website, it's taking up resources. And every time that CPU cycles, every time that memory is being allocated, you're paying for that. So the bots competing with you are causing your bill to go higher. So if you don't have a bot mitigation strategy for both performance and security concerns, you're already in a losing game. It's going to cost you more whether your site's up and running or whether it's been denied by users because you've been attacked by these bots. You need to have that in place and have a plan, because that's only getting higher and higher in the market. But with all these problems, I want to give you some good news. Performance engineers are here to help. Okay, we can help with one thing: optimization. Even if you move back things to on-prem or part of it, it's definitely not going to be what you had before. You are still going to want to have stuff out on the cloud, most likely. And so you're going to need somebody on your team that knows performance for more than just running a test and giving you some kind of analysis report or results and throwing it out there and saying, this is what it is. I ran a test, a tool jockey, we would call that. You need somebody who can help you actually optimize the system, whether they're running a load test or not, to recognize patterns, to look at various things to say, we could reduce consumption of resources if we made this architectural change, or if we change this technology stack that we're using, or maybe it's a minor thing that, like we were talking about CDNs, just putting and utilizing effective CDN policies can reduce the time of every web page and reduce the amount of resources that you're actually using. We really should, the performance engineers should be a decision maker's best friend right now when it comes to shifting to the cloud, because we want that cloud bill to go down as bad as you do, because that's what our job is. It's to optimize and get the most bang for the buck. It's not necessarily just about speed. Let's talk about this in a little more detail. Let me move this over and flip direction. So if we look up there, we'll see that performance engineer, if we start at the noon position, actually starts when you're designing the application, when you're building out the requirements documentation, when you're thinking about the contracts with vendors like SaaS vendors. You want a performance engineer there to advise you on, hey, here's some of the things we've done in the past that have really been bad for us and really hit us hard in a cost or resource consumption or anything like that. And then as we move clockwise around the circle, we see that a performance engineer would work with development to help enable them, make sure that they're running load test in the shift left capability when they build features and functions, that they're testing it that with the same answers they're looking for, same questions we're asking. Does it meet the performance requirements for one? Does it scale for many? And as we move again, we see that as we've traditionally operated within a QA framework, now QA in DevOps is sort of inherited into the dev category, but we still need somebody that has specific performance engineering skills when we're doing QA work, quality assurance, the performance part of quality assurance. Platform engineering, where we're enabling developers as a self-service model to give them the tools that they need to run those load tests and get those results in a continuous, integrated and continuous deployment pipeline. As we get into monitoring and observability, figuring out how our systems are doing right now. So we're doing that now with metrics, logs, and traces with observability platforms, or if you're still using a traditional APM product to monitor systems that are always there, knowing how they're doing. The key there is bringing in business context. Those companies who have cracked the nut around observability are ones who look at what the business is using the application for. When things go wrong, they know exactly what to look at, not too much information. They're gathering all that information, but they're seeing only what they need to see when they need to see it. Those companies are reducing the amount of time it takes to solve those problems that come up in production by over 90%. Now, those are the top tier companies who have figured it out. But think about it. If you could reduce the amount of time it takes for you to solve a production issue by 90%, think about how much cost savings and how much overall less work needs to be done to fix a problem in production. It's huge. Then we get into capacity planning and simulation and creating environments so that before we ever think about rolling something out into production, we've modeled out how we think that it's going to work, and we're using information from the operations side to build more effective test and load models that we know that our test mimic how users are actually using the systems in production. So we have a orange to orange test instead of an orange to apples test. So where's the real value coming from? In load testing and in performance engineering. This graphic is pretty simple. In DevOps, we have something called the golden signals, right? I call this the golden wheel of performance. And as this wheel begins to spin, what you find is as you access an application more often, more frequent, and you're increasing the quantity and you're increasing the duration of how you're using resources, eventually, if you don't do something, those resources will be over allocated. When one of the resources, CPU, disk, network, or memory, when they begin to be used up, you will start seeing degradation of your application, and eventually the application will go down. As you're using those resources, if you see on the right, the cost of that increases. So it's our job as performance engineers to keep that cost down, even though you're utilizing an application more frequently and longer. So what you're trying to do is keep that wheel from spinning too fast and out of control. You do that by properly optimizing the application, not just by making it faster. Sometimes by making an application faster, you're overutilizing resources and you're really not getting the most bang for your buck. But for the first time ever, we can look at a cloud application that's all in, and we can see line by line how much your code, how much poorly developed code is actually costing you per CPU cycle if we need to. And that has opened the eyes of a lot of decision makers, which is why they're moving back to on-prem, where you're not under necessarily that microscopic charging model or a more complex charging model, or the cost gets hidden a little bit in some cases. So as a performance engineer, the value comes from me being able to share with the decision makers the right story with the right information, not just coming into a meeting and sharing a bunch of charts and graphs and saying, look, I ran this test, here's what it is. Whether it's a load test that you're running or whether it's some other exercise where you're trying to figure out how resources are being utilized, the way you present that information is very important. So keep that in mind, that the value from a load test is in the analysis. The value from observability is in the screens and the charts that you create that make the most sense, that tell the story, what's going on, how are we doing, and how do we know how well that we're doing. And if we're not doing well, what does this data tell us about what we should do? We have to have some kind of an action we can take, make a business decision based upon your results, or the value of the testing and the engineering really isn't there. So let's talk about another important aspect of this, which is how we implement performance throughout the life cycle. So we used to think about load testing as an exercise much like cleaning our carpet with a steam cleaner. I mean, yeah, we vacuum, but steam cleaning, that's only when we have a really big mess, or once every 6 months to a year, we deal with that level of cleaning of the carpet. That's sort of how we felt with a really good in-depth load test of our application as a whole. Then we realized as Agile had us deploying applications more often, we needed to test for performance more often. And so we would utilize the dishwasher methodology, where it was at least once a day, sometimes multiple times a day. If code is being deployed multiple times a day, we should test multiple times a day for performance to keep up on it as much as possible and not be a bottleneck. Now we have to think about it like the refrigerator. It's always on, it's always doing its job, and it's always, hopefully, providing value, doing the work it's supposed to do. And that's how we have to think about performance. It's a continuous operation. And it starts from the shifting left and enabling the developers to do that level of feature functionality, getting the feedback as early as possible as it moves in to the right towards traditional QA, performance testing, the bigger picture, the integrated testing, and then over towards the right, looking at the observability and APM information that comes from the operations side, and then kind of marrying that together so that the right side begins to feed into the left side, breaking down the silos, making sure that your performance tests start mimicking the way users are actually using the application, keeping the business in context. Now, I realize that's a lot. And looking at this graphic, it seems easy to say, well, you just need to have performance continuous as part of your pipeline and part of your deployment. But don't think you're going to do this in just a day or two. This is something that's easier to say than it is to do. And it does have some complexity to it. And there needs to be a lot of thought put into how you implement this. And each organization is different. However, continuous performance is a reality today. It's not just a should have. I feel like it's a must have. And that's why the skill sets required to do this need to be there. Somebody needs to understand how performance fits into the life cycle, the whole life cycle of software in your organization, not just somebody that's been doing functional automation for years, or somebody who's a site reliability engineer who's been building infrastructure as code, and now all of a sudden, because they're slightly technical, they should know everything about performance or security for that matter. It's a specialized skill set, always has been, and probably always should be. So in summary, let's talk about what we talked about. Make sure that whether you are not going to the cloud, you optimize your application. Before you shift to the cloud, optimize your application. After you get on the cloud, optimize your application. Make performance a continuous activity. And remember, it's not just about load testing. It's about the value comes from the analysis that comes from the load testing when the business is in context. You should be able to have actionable data that comes out of all of your testing activities. If you can't create actionable data, you're not creating something that's of value. You probably shouldn't. You should be asking the question, why are we doing this? And the ability to tell a story to those who can make those decisions. This is what the data is telling us. This is what the test results are indicating. And because of that, this is what it's telling us we should do or should not do. This is a showstopper. Here's why. This is costing us too much money. Here's why. And here's what we should do about it. If you're not providing that level of data, you need to be asking yourself why you're doing that exercise, because there's other things you could be doing that would provide more value to your company. The great news is that if you can do that and you can keep the business in context, you will save the company a lot of money and potentially make the company a lot of money. And there will be no way that they could ever live without you. This is the era right now of the performance engineer. And if you're a performance engineer or wanting to become a performance engineer, this is your time. This is your time to shine. You should be the one that the executives and the decision makers are getting selfies with, because you should be the rock star, because you want the same thing that they want. You want a fast application. You want an efficient application, a less costly application, and a low risk application. That's what we do as performance engineers. And that's why we should be the rock stars of the company. So it's why it's important to think about performance with whatever you do when you're shifting to the cloud or shifting away from the cloud. Thank you so much for allowing me to be here to speak with you. I hope you got something out of this presentation. It would be great to have your feedback about it. If you want to know more about me, I'm Scott Moore, and I'm the host of 2 shows online. One's called The Performance Tour, which you can find out at that website, theperformancetour.com. That's a monthly show. I also have a podcast called the SMC Journal, smcjournal.com. That's a weekly show, and we deal with performance testing, tuning, observability, AI ops, and lots of other things on that show. You can also scan that QR code or check out those links and find me. I'm pretty easy to find on social media. Would love to hear your feedback about this presentation and anything else. It was great to be able to be here, and thank you so much to the Automated Software Testing and Quality Summit. Bye-bye.